Hello and welcome to another tutorial in our Siemens series. We're using step 7, version 5.5. We're going to create a new project. We're going to just pick 315 out of here, just random. I'm just picking these at random. And we're going to have it go ahead and load our organizational block. We're going to build it again in ladder. We're going to call it S7 tutorial 2. We're going to go into our hardware configuration. And in this series for the second tutorial, we're going to show you how to directly reference the input and output cards. So we're going to throw an input card into slot 4, and we're just going to grab an digital 8 input card out of our catalog here. It's towards the bottom, 120 volt. And then we'll throw the same thing, but we're using an output card, and it's 120 volt. Where are we at? Right here. Grab this one. Okay, so we're in slot 4. Oh, it's up here. Okay, we got the digital input card in slot 4. We have a digital output card in slot 4. And down here below, in the manifest, you'll see that our address for the input card, I, is starting at byte 0. And the output card is starting at output address Q.4 or Q0, or excuse me, the output is starting at 4.0. So byte 4 for your output, byte 0 for your input. We'll go ahead and save. We'll go ahead and compile this, and we're going to save it. And same thing, save and compile, save. And we'll close. We're done with the hardware. So we're set up, we're ready to go. So we're going to go ahead and open up our block routine here. We'll switch this over to, we'll open the block file and we'll switch over so that it's in list view or details. And then we'll go ahead, here I'll go ahead and make this a little bigger. And we're going to add a function block to this. We're going to name this, it's going to keep the same name for us, FB1. Give it a symbolic name for line 1. Just a random name we made. You put any comments in that you want. We're going to create it in ladder. We're going to open that up now. And we're going to just directly reference our inputs in this one, and then so I can show you how to use the simulator, referencing your actual program that you're designing. So we'll just make a simple latching circuit. So when you normally open, normally closed, an output, and then we'll just jump around here, and there's our latching circuit. So we have all these set up here. So we'll go ahead and minimize this. So we're going to go back here and do something a little new. We're going to go into the program. We're going to go ahead and create our symbol list. So we'll go ahead and start with 3 here, and then we know that we're going to need a start push button. So the symbol name is going to be start push button. The address, remember, if you forgot, minimize this. We'll go back to our hardware configuration, open it up. So our input address for our input card in slot 4 is starting at byte 0. So it'd be I0.0 would be the first one. So we'll go ahead and open back up our symbol list here. And so we're going to use I 0.0, and we're going to call this our start push button. We're going to need a stop button, so put in the stop PB for the symbol name. As you notice, it went ahead and indexed it to the next available input, which was I0.1. And this is going to be our stop push button. And then we just need our control relay or output. Let's see, CR1. It indexed to 2, but remember that's an output. And if you go back and look at our hardware configuration, our output is starting at byte 4. So we're going to use Q4.0. Q 4.0, and this is going to be the control. It's our control relay, but we're going to say this is our starter coil. Then pump 1. All right, we can save this list. Close it. We're done with the symbol list for now. We'll go back to our function block, which is function block 1. Now, if you just type in start, there's your start push button right there. And we'll go to the next one, which will be our stop push button. And our control relay, which was CR1. Again, CR1 for the latch. Okay, as you see that our symbol list here is, that's our symbolic name is start push button, and it's referencing input 00, our stop push button, and it's referencing input 0.1. Then we have our starter coil, which is pump 1, which is control relay 1, and it's referencing Q 4.0. The same thing down here. This is a good network for simple latching system here. So we'll go ahead and we'll save it. We're going to go ahead and close. We'll need it here in a little bit, so we'll just go ahead and minimize it. Now we'll go back to our blocks. We have to go to our organizational block, and now we need to call that function block we just made. We'll go ahead and drag it over. We'll drop it in the first network. As you notice, we have some red question marks here. It's because we're using a function block, and function blocks require data blocks. So we're going to go ahead and just type in db1. I know data block 1 is not being used, so we're going to go ahead and just use it. It's going to ask us if we want to create it, the instance data block, and yes, we do. Alright, and we can go ahead and save this. We'll go ahead and close it because we won't need to come in here and monitor this. We know that it's going to scan and only do what we tell it to do. That'll be the first scan. So we'll go over here to our options, and we'll scroll down to where it says simulate modules. We'll go ahead and open this up. Now this already had set up prior. We'll just go ahead and get rid of these. And so when you start this up, and if you haven't before, you'll have just the CPU come up. We're going to want to add, and you can use little quick buttons over here. If you leave the mouse over it, it'll give you a snapshot of what it is. So it's be insert input variable, and that's what we're going to use. And then we're going to need an output variable as well. So these are your two cards, and we're going to go ahead and we're going to have to rename these. So we have an input card, and it's starting at 0, which is correct from our hardware configuration. If you remember, we started at 0. And then we have an output card. It says it's starting at 0, but we need to start it at 4. So we'll change the 0 to a 4. And now we have that ready. So we'll go ahead and come over here. We'll close the hardware configuration. We don't need it anymore. And now that we have our simulator set up and ready to go, we're going to go ahead and highlight these 3 blocks because we need to download all 3 blocks to the processor. We'll go ahead and use the download button here. And it downloaded everything to the simulator. Now if we pull the simulator up, let's put it into run program. Now it's running. We'll go ahead and open up our function block, which we didn't. Oh, we did close, didn't we? Yes, we did. We'll open up the function block. We'll grab our simulator so it's on top. Now we'll go here and we're going to monitor this routine or this network. As you can tell, we are connected with the processor. You can tell because our bus rails are lit up, and they're stopped because this is true. We need to make it false so that's closed. And then I'll go ahead and go through, and it should turn on pump 1, and then it'll latch pump 1. So remember, here's your input card, and we're going to reference 0.0, and so that would be 0.0, which is right here. So when I toggle this bit on, we should latch the circuit, and output 0 should come on. Let's go ahead and do that. Output 0 come on. I'm going to remove this, and this is now open again, but because we latched our output on, we're holding it in and it's keeping it on, and it's showing an output here on Q4.1. So altogether, in a nutshell, this is how you reference your actual output cards with the S7 simulator. Now we're going to do something a little different. I'm going to take it a little further. So we'll go ahead and we're going to stop it because we don't need it running. And we can go ahead and stop monitoring it. Now what we're going to do is we're going to take, because we're using a function block, we can do this. And this is why there are the data blocks used. So we're going to go ahead and come up here. We're going to change this and use this so it's going to be basically like an add-on instruction. If any of you guys are familiar with any of the Alan Bradley's Rockwell software for RS Logix 5000, you can build add-on instructions, and that's basically what we're going to do with a function block. So we'll highlight the N, and we're going to go ahead and call this start button, start push button. And we're going here. Let's make this just bigger so we can see it. And the data type is going to be a Boolean. Its address is within the block here of 0.0. Now we'll make a stop push button. It's Boolean as well. Let's come over and give these two comments for in the block. Always great to do to help fellow programmers out when they go through and try to troubleshoot things. So this is a start push button. Even though they're kind of simple and self-explanatory, we're still going to do it for consistency. So, and the next one's going to be a stop push button. Okay, now that we have our comments put in, we're going to go ahead and grab the output here, and then we're going to put in our control relay, which was CR1, and it's also a Boolean. We're going to call this starter coil because you can reuse this function block and use different data blocks. Okay, now that we have these in, we're going to go ahead and change these here. So if we type in S for a start button, now here's the difference. These here are, excuse me, what you see right here is from our symbol list, and this is from within inside the function block. So we'll select that one, and as you can tell, it's referencing this right here. So remember that tag, and I'll show you. Oh, we put the wrong one there. We'll go ahead and change that. Right here, the start button. So you're going to want to use this because they match. It's a good way to look at it. Go here. We'll use the same thing for stop. Grab the stop one. And do the same thing for the control relay one. And we'll do it right here as well. Okay, see, so the hashtag or pound symbol is a reference with inside of the block. Okay, we're going to go ahead and save this. Yep, we're going to go ahead and save it anyway. Now, we'll go ahead and minimize this window. We need to come back here to our organizational block, and we need to update the block itself. So there's a timestamp conflict. We'll just select OK. It's in red. We're going to open this up. Now what you do here is you're going to right click. You're going to go down and say we want to update the block call. And this is what it's going to give us right here. We'll say OK. Yes, we still want to do that. Alright, now from the organizational block or your main program suite, whatever you want to call it, we are going to directly reference our inputs. And that way we can always use this block again with a different data block, so we don't have to, if we want to make one for VFD or other numerous things and we want to reuse that block throughout the program, we can. And this is one way to do it. So this one, remember, is our start button. So we'll just type in start, and as you notice here, we do not have those reference calls for the. So we can go. We know that this is going to be good because the little light blue color or whatever color may show up on yours is going to reference your symbol list. So we want the start button. Where's the start push button? Then we want the stop button, and then we want our control relay, which is our pump. Okay, so as you tell, they're referencing the same thing. So we're going to save this now, and we're going to go ahead and shrink this up just a hair. Oop, I didn't want to do that one. We'll do the whole thing. Go here, and now we need to download these. We don't need, we're going to need to download the whole thing to the processor. It's going to ask us if we want to override it. Yes, we do, to all of them. Yep. Yep. Okay. Now we're back to where we were. Let's open up the organizational block, and let's show our simulator here. Let's go ahead and monitor this. Now we have a 0 because we're not we haven't put a check mark here to change it from 0 to 1. The stop bit is the next one, and then our output 0 is our starter coil. So basically the same principle. We're gonna push the start button, so we'll put a 1 in here, which is going to run the logic that's inside the block, and it's going to give us our output, which fired that coil, that starter, or whatever you have going outside of it. Now we can go ahead and not monitor this one. We can go directly back to that function block, which is right here. We can monitor it. As you can tell, I left the check mark on, so it sees that the check mark's still there. Take check mark out. It's still doing the same thing. Hit stop, turn the coil off. So we can reuse this block over and over and over again with different data blocks. And we'll do that real quick. I'll show you an example. Stop monitoring this. Go ahead and exit that. Close this up. Back to our organizational block. We will go ahead and add another network. We'll scrooge this up. We don't need to see as much. Now we'll insert by right clicking. We'll insert a new network, and we'll grab that same function block. We'll throw it over here in the mix. And since we're using data block 1 there, we'll use data block 2 here. We'll need to create the new instance block. Yep. Okay. Now here we're going to do something a little different. We're not going to use I'm not going to go back and make a new symbol list. We're just going to use the next available input, which was input 0.2, and then we're going to use input 0.3 and output Q 0.1. Okay, these are referencing the outputs, much similar to this. Now this is what you would see if you didn't have your symbol list with you. When you bring it online, you'd see just this itself. Now there's two things that we're going to have to add or download separately to make this block work and run the same. And we'll go ahead and we're going to save this. We're going to go ahead and close it out. We're going to come in here, and you'll notice we have this new instance data block made, and we need to download this and then download the organizational block, otherwise you can fault your processor. So we'll go ahead and download the data block. Done. And now we'll come up here and we'll download the organizational block. Yes, we want to overwrite it. If you come back, we're not in fault, so we can come back to our open this up so we can view it. We'll do the same thing. We'll shrink that up. We'll grab the simulator one more time. We'll scroll down the list to the next one. Almost had enough room. Let's pull this up a little further. There, we got both here now. Come up just a hair so we can see the data block number. Okay, we'll go ahead and turn this on, monitor this. So remember I said we use the same function block 1, and this is line 1. You can change this name to something else. or this could be the second conveyor on line 1. But if you change his name, then it'll change. Where you want to do it is your data block instance. So that's what the one is, like conveyor 1, conveyor 2. That's where you would give that a comment name. So here we'll go ahead and show you. Go up here on the first network so it does both. Alright, so we're going to start with 0 for the first function block, and you can see that output's on and running. And now if we skip and go to 2, which is this input here for this start push button, the second one should come on. And I did it in reference there. Why is that? Oh, okay, my fault. Remember we started at 4. Let's we're gonna change it. We gotta go offline here real quick. Change this to a 4. See how easy it was to find a mistake. We'll go ahead and download this one. Yep, we'll overwrite it. Then we'll go back to monitoring it. And now you can tell that because we had started this routine, it was already still latched on because we never stopped it. It went and updated. So we'll go ahead and we'll stop using input 3, which turned that one off. We'll stop using input 1, turn the other one off. Again, we'll come back and start it. 2 on, 1 on, and that's kind of the whole thing in a nutshell. On using those as a trying to use them as an add-on instruction. I'm pretty sure I went a little bit too fast and a little too far in detail in this one, but I wanted to kind of show you guys both aspects of this. And remember, if you want to see things updated, it's only going to update anywhere below where you have it highlighted. Okay, now that you've seen how that works, what I'm going to do is we're going to go back and we're going to take a look at our data blocks. So we're going to go ahead and unmonitor this. We can close it. We're not going to go back and look at it. The block was changed. Yeah, whatever. Okay, so we're going to go back and we're going to look at our data instance blocks, or instance data blocks. So we're going to open up data block 1. We're going to go ahead and show our simulator, and what we're going to do is we're going to monitor this block. So if we monitor the block, it's going to show that its actual value, whether it's true or false. These are what the data blocks hold. They hold your values from your function block inside of each one of these. If you want to add different things, come in and monitor them. You can monitor your whole block real quick right here to see what's going on. So if I go in and I check mark 0.0, it's going to update and turn that to true. So we'll go and do that. As you can tell that the actual value right now is true, and then you notice the coil started. So we can take that out of perspective here. So the coil is running, and now if we're going to stop it, we'll go ahead and use the stop button, and we'll turn that true, and you can see it updates. So it kind of shows you what's going on inside those data blocks. I know I was all over the place a little bit in this. I threw a lot of information at you. If you have any comments, please leave them below. Let me know what I can do to help improve these tutorials. Maybe slow down a little bit with the Step 7 software. I kind of flew through this one, but I hope you get the grasp of it. I thank you for watching. Please don't forget to subscribe to stay up to date with our newest tutorials.